Again, welcome to another mechanical science video. A bit more on fluids today, in particular these two bits of terminology here, pressure and thrust. Alright, so let's have a little look at our formulas. So first thing that we're going to have a little look at is this hydrostatic thrust. Alright, so we've got force is equal to rho g a x. Now to get our head around this, I'm going to have a little look at pressure first of all. So it would be, as we've seen in our introduction video, if we've got a container, badly drawn container, if I put an object in this container, the pressure increases the further that object goes into that container. Alright, so the pressure that's acting on this object is dependent on the height of that object. Now the density is the density of the fluid. Okay, gravity is the gravity that's acting upon that object. And this x is the height of that. Okay, now you might have seen that written as rho g h, but x is the term that we're going to be using. We've got our different symbols here. So we've got pressure, rho, gravitational constant 9.81, and then height. Now you remember from our statics topics, pressure is measured in pascals or Newton meters squared, either one of those units, but you've got to have some units on an answer. Okay, next one, if we've got force, and then this is the actual formula that's given to you on the formula sheet, is force is equal to rho g a x. Now x, height of the fluid, a, the surface area that the fluid's acting on, more of which in a moment, g, gravitational constant 9.81, and then rho is the density of the fluid, and force, as you remember, the answer is always in newtons. Okay, so let's have a little look at solving one of these problems. So I've got a fluid, a tank that's got some water in it. Yeah, that's fresh water. That's important because that's going to give me my density. It's rectangular shape, 6 meters long, 4 meters wide, and the water's height of 3 meters. So you can imagine that it's got 6 meters here. Oops, 6 meters, 4 meters wide, and then we've got fluid is at 3 meters. Alright, so let's go through, we'll make a little list of the known values and then we'll start to solve these problems. So pressure is the first bit, force is the second bit. Okay, so to answer the second section we're going to use that, but we're just going to introduce that pressure calculation. So let's go through. Okay, so we've got length, 6 meters, width, 4 meters, the height of the fluid, x, 3 meters, density, fresh water, and you again check out previous videos if you don't know where we get this value from, is 1000 kilogram meters cubed. Okay, so we're going to solve this first bit. Now pressure is equal to, let me go back to school with that spelling, is rho g x. Alright, so g, gravitational constant, rho from our density, so we'll do a p there for pressure, so we'll have 1000 times 9.81 times x, which is the height of the fluid, which in this case is 3. Alright, so the pressure is going to equal, I'll give you a sec to pop that in your calculator, if you hit your ENG button, yeah, so get ENG 29.43 times 10 to the 3 units for pressure, pascals. Okay, so I'm going to pop that down here, 29.43 times 10 to the 3 pascals. Okay, right, next bit. First bit in the bag. Next bit, force exerted by the water on the base. Okay, so the base of this tank here, quite a big force is going to be applied to it because we've got a lot of water above it, but our formula for that one is going to be force is equal to rho g a x. Alright, now slightly trickier in that we've got this area to think about. Okay, so let's have a think of the question. The force exerted by the water on the base of the tank. Okay, so we know the base of the tank is along here. So the area is going to be 6 times 4. So let's pop some numbers in there. Alright, so we'll go density 1000 times 9.81 times the area, 6 times 4, get that in some brackets. Alright, don't be scared to pop that area as a separate calculation if that makes you feel a bit better. But x is the height of the fluid, and that's 3. So the force is going to equal, so we've got, hit your ENG button again, 706.32 times 10 to the 3 newtons. Different units this time, pressure and force. So force is going to equal 706.32 times 10 to the 3 newtons. Okay, so if you're thinking of this as your exam question, you've got formulas, answer, units, formulas, answer, units. Alright, so if you get top marks for that. Okay, now let's have a little look at the next one, which is slightly different, alright, in relation to this bit of information. So I'm using the same dimensions just so that we're familiar with what's going on here. Okay, so I've still got the same tank, 6 meters, 4 meters, fluids at 3. Alright, but rather than calculating the force on the bottom of the tank this time, I'm actually going to be calculating the force acting on the side of the tank. Alright, so let's go back through again. We'll do length equals 6 meters, width equals 4 meters, x is 3 meters. Alright, now the tank itself might be 5 meters tall, but the fluid is only at 3 meters. Alright, so it's the height of the fluid, not the height of the tank. Obviously you can't have fluid, the dimension can't be greater than the height of the tank, because obviously it would just flow over the top, but bear that in mind. And then fresh water again, so we've got density is 1000 kilogram meters cubed. Okay, now let's get our formula up here. So hydrostatic thrust, alright, which is what we did in the second part of the last question. Same formula, rho g a x. Now this is when this becomes slightly different. Now what we're going to do is we're not calculating the force acting on the bottom of the container as I previously mentioned. We're calculating the force acting on the side of the container. Alright, so that's going to change our area calculation. Alright, but before we do that, we need to give this x some consideration. Now when we're talking about fluids, and we're talking about fluids acting on the side of objects, so vertical shape here, yeah, or vertical side, the fluid acting on there, it's calculated separately by doing something called finding the centre of pressure. Okay, now for the sake of this argument, we're going to use the centre of pressure as x divided by 2. Okay, now you may also see it written as x divided by 3, which is actually the more accurate way to do it. But for this activity and any of these exam questions that you're going to get, we're going to do centre of pressure is x divided by 2. Alright, so basically we're finding a distance here. Okay, so that distance is dependent on the height of the fluid itself. So let's go ahead, we'll pop some numbers in. So force is equal to 1000 times 9.81 times the area. Now the area that we need is the area of the side of the tank, so that's 4 times 3, not the 6 previously because that's the length. Alright, and then our centre of pressure is going to take our x, which is the height of the fluid, and we're going to divide that by 2. Alright, now if you can remember, you can do it by 3, you actually get a more accurate answer, and there's a reason for that which we're not going to go into in this video. So I could do deriving formulas and all that jazz, but divided by 2 is plenty accurate enough for us. Okay, so we'll do force is equal to, and I'll give you a second to pop that in your calculator. So force is equal to 176.58 times 10 to the 3 newtons. Alright, and again, that's your hitting the ENG button on your calculator will get you in standard form. So force equals 176.58 times 10 to the 3 newtons. Okay, so it's exactly the same as we did in the previous one, all right, on this section here, but it's this value here that's changing if we're talking about center of pressure on the side of containers as opposed to on the bottom. All right, now we'll be doing some more practice ones of these, but as always there's some practice ones both in your workbook and on Canvas, but just a quick introduction to pressure and hydrostatic thrust. Now, word of warning, I've just remembered this here, is this area, yeah, dependent on the shape. Okay, so obviously it might be a circular shape, it might be a rectangular shape, it could be all sorts of different shape, but the area, you might have to swap your calculation over there. Alright, so once again, thanks for watching, and don't forget there's plenty of practice ones of these in your workbook, and if in doubt, give me a shout, and I'll catch you in the next one. All the best, bye bye.